Well, in this lecture we will be studying Newton's divided difference method. This is the third method by Newton for interpolation. The first two methods were we studied those methods, Newton's forward interpolation and Newton's backward interpolation. So this is the third method given by Newton's divided difference method. Right. This is also an interpolation method, but it is for unequal intervals. The previous two methods we studied yesterday were for equal intervals, but this method is for unequal intervals in X. Right. So the same, we will be given a data table where one column, the first column will be for X, the second column will be for Y, and we have to find the value of Y for a value of X that is in between any two given values of X in the table. And f of x naught or y naught would be, we would compute y naught or f of x naught using this simple formula. The formula is very simple. F of xp, the base value is the same as we studied for Newton's forward interpolation method. The base value, the value of x, that is for the previous, in the data table, the value of x that is just before x naught. For example, here if it is x naught, xb would be x2. Right, the same xb that we studied for Newton's forward difference method. Then plus x naught minus x1 is, x naught is this value, the desired, the given value of x that is in between the values given in the table, minus the first value in the table, the first value of x in the table, times del y, and I'll shortly tell what is del y, and then x naught minus x1, the same, times x naught minus x2, the value of x for which we have to compute y, minus the second value of x, del squared y, and so on. Right, but del y is a bit different from the del y that we computed for Newton's other two methods. This del y is divided difference method. Since the method is divided difference, so del y is not only the difference between the two values of y, but it is divided by the difference of x. So this is actually y2 minus y1 over x2 minus x1. This is the difference. This is the primary difference between this divided difference method and the forward and backward interpolation methods that we studied yesterday. So this is a divided difference, as the name suggests, divided difference. So we have to divide it with the difference of x. Right. So actually we go like this, we go diagonally, and then we go straight to find the values of x. To find the values of x, which we have to divide in the denominator. Right, and for this is the difference in the numerator, then differences of y, the difference of y and the difference of x. So 45 minus 30 is 15. And for this is 0.866 minus 0.707. The difference of y is in numerator, and the differences of x is in the denominator. 60 minus 50, 45 is 15. And then del squared y finally is del cube y, I forgot it. Right, del squared y, for del squared y we have to divide these we have to subtract these two values, this value minus this value divided by the difference of x. How would you find the difference of x? The difference of x is, we'll move diagonally and unless we reach y, and then we'll go straight horizontally to 0, and we'll go diagonally, we'll keep on moving diagonally unless we reach here, and then we'll go horizontally to reach 45. So this is 45 minus 0 is 45. And for this, the difference of these two value appears in the numerator, and the denominator is, right, we'll move diagonally unless we reach to the y, and then we move horizontally, we reach to the value 30, and we'll move diagonally, and then we move horizontally we reach the value 60. So 60 minus 30 is 30, right? And then we'll subtract these values and the difference appears in the numerator, and we'll go keep on going diagonally, and then straight horizontally 0, and then we'll keep on moving diagonally, and then horizontally we reach to the value 60. So 60 minus 0 is 60. So this 30 comes out to be as 30 minus 0. This 15 is actually 45 minus 30. This 15 is 60 minus 45. This 45 is 45 minus 0. This 30 is 60 minus 30. And this 60 is actually 60 minus 0. So it's divided difference. So now we have all the values available. 30, this is 15, this is 15, this is 30, 45 and 60. Now we have all the values available, and now we can plug these values in here. Suppose we want to find out f of 10, and we studied yesterday that f of 10 is approximately 0.7 for this sine of x, f of 10. So f of 10 is f of 0, f of 0 is 0, the base value is 0, f of that is also 0, so x0 minus x1, x0 is 10 minus the first value x1 is 0, 0, del y, now again we'll move along the diagonal like this to find del y, del squared y and del cube y. So del y is 0.5 over 30 plus this is 10 minus 0, x0 is 10, x2 is 30, del squared by 2.8 10 to the minus 3 over 45 plus x0 is 10 minus x1 is 0, x0 is 10, x2 is 30, x0 is 10, x3 is 45. Del cube y is minus 0.07, 10 to the minus 3 divided by 60. So you work with this and you reach to a value approximately equal to 0.19, and we studied yesterday that using a calculator we reach to a value 0.17 for sine of 10. So this value computed using Newton's divided difference interpolation method is very close to the actual value. Right, that's all for this lecture. Thank you.